John Galecka is investigating whether the processes which built Everest continue to this day. He has traveled to the remotest regions of Nepal and India, setting up GPS stations, which he hopes will provide him with the answer.
All right, come as far as I can by car, and I've got a 3-hour walk straight up the slope. Namaskar.
Just like a GPS in a car, this station is able to pick up signals from satellites and monitor any movement of the ground.
The GPS station has been operating continuously for the last 5 years, so every second of every day of every month of every year, it's taking a data sample, and what it's looking for is changes in the position of where the station is, but how it's moving, the velocity of this station, believe it or not, and even changes in velocity.
The readings from the GPS show that India is still moving, about 2 inches every year. 50 million years after its initial collision, it is still on its relentless journey northwards, pushing underneath Asia. And as it does so, Everest continues to be pushed higher. But there is a dark consequence to this mountain building. Earthquakes.
So what's going on here in the Nepal Himalaya, we've got the Indian tectonic plates sort of ramming into Asia. In this case, India is losing out. It's being forced under Asia. But it's unfortunate that they're locked frictionally, and eventually, over the course of hundreds of years, that strain is accumulated and then released suddenly in a giant earthquake.
The Himalayas have seen 15 major earthquakes in the past 100 years. The most recent to hit was in Pakistan, October 8th, 2005. The quake devastated the region. Galecka's readings show that another earthquake is on its way. Kathmandu, the capital of Nepal, lies in the center of the danger zone.
When that earthquake happens, not if, when that earthquake happens, it's going to be several minutes of terror. There'll be strong shaking, in Kathmandu. There'll be just collapsed structures. You'll see landslides on all these mountains. It's going to be complete devastation. 26 million people in Nepal, 50 million people along the whole arc of the Himalayan range. All of these people will be affected.
These devastating earthquakes are the result of a very active mountain belt. Further evidence that Everest is being actively pushed upward. But there is a second force at work in these mountains: erosion.
There's a constant battle going on in nature here between the uplift of the Himalayas and the down-cutting of erosion.
Erosion in the Himalayas is ferocious. A clue as to the reason why lies in a small village 300 miles east of Everest, Cherrapunji. It's the wettest place on planet Earth, averaging over 432 inches of rain each year. This place is 12 times wetter than Seattle. And the reason for all this rain? The monsoon.
The Indian monsoon system is an almost unique system on the planet. And the ultimate driving force is the high mountains and the high Himalayas and the Tibetan Plateau, which is by far the largest area of high elevation on the planet today. And that causes this massive high pressure system during the summer months, which results in the sucking in of all the warm, moist air from the Indian Ocean.
This seasonal weather system blows in across India. Clouds build and rise as they hit the high mountains and form heavy rains which fall across India. Those rains reach their maximum on the southern slopes of the Himalayas.
During the height of the summer monsoons, some of these rivers are able to rise by 20 or 30 feet in one storm. So where I'm standing now, the levels of the river will be way up over here.
Each year, 264 cubic miles of fresh water, enough to fill Hoover Dam's Lake Mead 30 times over, pours down the slopes of the mountains. This water feeds some of the largest rivers in the world: the Ganges, the Indus, the Irrawaddy, and the Yangtze. The Himalayas are the water tower of Asia, supplying fresh water to a fifth of the world's population. But all this water is having a dramatic effect on the mountains. Fast-flowing rivers cut steep-sided valleys. High in the mountains, rain turns to snow, feeding glaciers which carve into the upper slopes. All these forces are at work today, wearing away at the Himalayan peaks.